Hello and welcome to our today's lesson. We are going to look at a topic, expressions, equations, and inequalities. And to begin with, we are going to look at algebraic expressions. Now, in defining algebraic expressions, it is important for us to understand that algebraic expressions are simply mathematical statements that tend to express mathematical values or questions. So expressions are mathematical representations of statements by use of what you call pronumerals. Pronumerals are simply the alphabetical letters such as A, B, C, and D. We are going to understand some of the terms that are normally used in algebraic expressions. There are 5 main terms, and these are: 1, pronumerals; 2, a term; 3, coefficient; 4, a constant term; and lastly 5, squared term. We're going to look at a description and an explanation and a definition of each of these 5 terms that are normally used when it comes to algebraic expressions. If, for example, we are given an algebraic expression of the form 5x minus 2xy plus 4a squared minus 2. This is a good example of an algebraic expression where we are using alphabetical letters x, y, and a to represent some mathematical statements. In this particular case, we want to derive or come up with these 5 concepts that we have highlighted. So for the pronumerals, we have said they are the algebraic or alphabetic letters, and therefore number 1, for these pronumerals in this particular algebraic expression, we have x, we have y, and we have a. So we have x, y, and a. They are what we call the pronumerals or the alphabetical letters. A term. A term is normally connected by use of either multiplication or division. And in this particular algebraic expression, there are different terms, or there are several terms. So if we look at this first term, 5x, we can be able to say that 5x is a term because it's consisting of pronumerals and numbers, and they are connected by a multiplication. This is like 5 multiplied by x, which will give us a 5x, and therefore 5x is a term on its own. When we consider this second, minus 2xy, is also a term on its own. If we look at this 4a, it's a term, that is a number and a pronumeral connected by a multiplication sign. Therefore, it's a term. Then, for the terms here, we have 5x minus 2xy. We have 4a squared. And then finally, we have a 2. 2 is also a term on its own. And consider this particular negative sign. Therefore, it's going to be -2. So the terms, this particular expression has got how many terms? 1, 2, 3, 4. It has got 4 terms. Third, coefficient. Coefficient simply means what comes before a particular pronumeral. And if you consider this, all these terms, each one of them has what you call a coefficient, a number that comes before it. In the first term, 5x, it has a coefficient, that is a number before that particular pronumeral. And the number in this case is 5. Therefore, you can be able to say that the coefficient of 5x is 5. The coefficient of this particular term, minus or -2xy, is -2. And we consider the negatives or the sign before that particular number. -2 is before xy in that particular term, and therefore -2 becomes a coefficient of -2xy as a term. If you consider this as the term 4a, 4 is the coefficient of a, and therefore 4 becomes a coefficient. So the coefficients in this particular expression are 5, -2, and 4. There are 4 coefficients in that particular expression. Number 4 is a constant term. A constant term is a term that is not changing. That means it is there permanently. If we consider these particular expressions and we add different variables of x and y, we will discover that there is one part that will always remain constant or not changing. That particular term is -2. Because if we had different terms or different values for x and y, of course this particular term will change. This one will change, this one will change. But a constant term or a term that will remain constant all through that particular expression is -2. That is what we refer to as a constant term. Always remember the sign before that particular term. It is very important. The last term that we need to understand is a squared term. Now, if you look at our expression, there is only one term that has a square or that has been squared. And in this particular case, if you check through, you'll discover that 4a has been squared. And therefore, you can be able to say that a squared term in this case is 4a. In dealing with mathematical or algebraic expressions, we normally have 4 different operators. That is addition, subtraction, multiplication, and division. They are what we call the operations in mathematics. But whenever we are dealing with algebraic expressions, we always begin by opening up the brackets. So the first thing we do, that is order of operations. We are saying that there's a particular order that must be followed whenever you are evaluating algebraic expressions. Number 1, we always begin with brackets. That means you evaluate what you have inside the brackets first before proceeding on. Number 2, you should consider powers. So if there's any term that has a power, you work it second. Then third is multiplication. And division. And then the last thing that you do evaluate is addition and subtraction. So this is the order of operating algebraic expressions. So you begin with opening up the brackets, then you proceed to the powers, then you do multiplication if it is there, followed by division if it is there, then you move on to addition, and finally you subtract. Example, write an algebraic expression for this one: number of tickets needed by 3 boys and are girls. So you discover that in this particular question we are having 2 genders, boys and girls. We have 3 boys and we have are girls. These individuals want to obtain some tickets. So the tickets that will be required by the 3 boys and are girls will be the sum of the number of tickets required by boys plus the number of tickets required by girls. And because each boy requires 1 ticket, each girl requires 1 ticket, the solution to this question will be the number of tickets will be 3 added to the number of tickets required by girls, which is R. B. Cost of pea pies at $3 each. We are having pies which are costing 3 shillings per pie. So if you want to get or to obtain the cost of purchasing pea pies, in this particular case, P is a pronumeral, and therefore you can be able to get the total cost of the P number of pies, which you take the 3 pounds multiplied. You take the $3, you multiply by the number of pies, which is P. This one will give us a total of $3p. Number of grams of peanuts for 1 child if 300 grams of peanuts is shared equally among C children. In this particular question, we have a total of 300 grams of peanut, which is supposed to be shared equally among C number of children. That means each child will get a share of these 300 grams, and therefore the peanut worth 300 grams is going to be shared into C parts. And in that case, each child will get 300 grams divided by the number of children, which is C. Each child will be able to obtain 300 all over C grams. Another example, write algebraic expressions for A 5 less than X. In this particular question, we have 5 less than x. So the solution for this particular case will take the value which is x, will less the amount or the number which is 5. So this expression simply means 5 less than x. Number B, 3 more than twice x. In this particular case, we don't have less, we have more, and it is 3 more than twice x. We therefore need to write an expression for this twice x, then 3 more, or 3 more is added to it. Therefore, we're going to have a total of 2x added to 3. This simply means twice x. C, the sum of A and B. Now, for us to be able to take or to write this expression, we need to understand what the word sum means. Sum simply means addition, and in that particular case, the sum of A and B will be A added to B. So that will be A plus B. D, the square of the sum of x and y. In this fourth question, we are talking about the square of the sum of x and y. That means we first need to come up with the expression for x, for the sum of x and y, and then we finally square it. So the sum of x and y means we add x plus y, and then to finalize, we square the sum of x and y. It will yield x plus y squared. Substituting values, into algebraic expressions. Example, evaluate these expressions if the value of A is 5, the value of B is -2, and the value of C is 3. Part A of the equation, we have 7A, subtract 2 into A minus C. In this particular question, we are supposed to substitute the values of the pronumerals into these particular expressions. If you look at this expression, we have 7A, subtract twice of the difference of A and C. The first step in solving this particular expression is by doing the substitution. Where there is A, we put the value of A, which is 5. Where there is A, still we put our value of A, which is 5, and where there is C, we put the value of C, which is 3. So in that particular case, the solution will be 7 multiplied by A, and our A from that one is 5, subtract twice of A minus C. Our A is 5, and our C is 3. When we solve this, you'll get that 7 multiplied by 5 is 35. Subtract 5, subtract 2, subtract 3, you get 2. So we shall have 2 multiplied by 2, which will give us 35 less 2 by 2 is 4, which will give us 31. So in evaluating, we solve, and we have gotten that the value of this expression, when we do the substitution of A and C, we get the answer as 31. B squared subtract AC. Again, the first step in solving this particular question is by making the substitution. Where there is B, we put -2, or the value of B, which is -2. Where there is A, we put the value of A, which is 5. And where there is C, we put the value of C, which is 3. So in that case, B we have said is -2. So we are having -2 being squared. Subtract the product of A and C, and our A is 5, our C is 3. In this particular case, when you square -2, you get +4. Subtract. When you get the product of 5 and 3, you'll get it at 15. So when you subtract 15 from 4, you will get -11. The answer for this question number B is 11, and that is substitution. Other examples, example 4. State the number of terms in these expressions. Number 1, we have 5x plus 2y. In our introduction on algebraic expressions, we said that a term is a single number that has been united or that has been connected by use of either division or multiplication sign. And therefore, in this case, you'll discover that 5x is a single term or is one term because it has been connected by multiplication. That means we have 5 multiplied by x. Then this 2y is another term. That means we are having 2 multiplied by y, giving us 2y. And therefore, in this particular first example, we have 2 number of terms. That is 1, 2. B squared plus CA minus 1. If we again look at this particular question or expression, you'll discover that there are several terms which have been connected. The prenumerals and the numbers have been connected by either multiplication or division. And in that particular case, this B squared will be a term on its own, CA will be a term on its own, and -1 will be a term on its own. Therefore, we have 1, 2, 3 terms. C, x squared over 2. Now, if I write this expression, it can be rewritten as a half x squared. The coefficient of x squared in this particular case is a half. And because the coefficient and the pronumeral are connected by a multiplication sign, then the whole of this become a term, and therefore in this particular case we only have one term. There are a number of terms which are normally used simultaneously or similarly to mean one or the other thing. So I like to look at such case as example 5 by matching an item in left column with item in the right column. We simply have terms or new terms. One is product, B, sum, C, difference, 4, quotient, 5, square of x, and 6, 1 over a. On the right column, we have division, subtraction, multiplication, addition, reciprocal of a, and finally the square of x. Now these terms and also the other terms are normally used consistently and simultaneously, always interchangeably, and therefore we need to understand which term can mean which term at which particular time. So product, we can be able to match it with multiplication, because when you are told to find the product of maybe a and b, that means you take a multiplied by b, which will, when you simplify, it will give you ab. Therefore, the product is the same as multiplication. Sum. When you're told to get the sum of a and b, that means we add the two terms, and therefore sum we can also use addition instead of the word or the term sum. Difference simply means subtraction. So when you're told to obtain the difference of a and b, that means you get, or you take a, subtract b, or you subtract b from a, and therefore difference means subtraction. Quotient is normally used whenever you are dividing terms. For instance, when you get told to obtain the quotient of a and b, that means you take a, you divide it by b, and therefore quotient simply means division. So we can either use division or we use quotient. Square of x is simply synonymous to that, the square of x. Then 1 over a is the same as the reciprocal of a. So the reciprocal of a is 1 over a. Evaluate these expressions. If a is equals to 4, b is equals to -3, and c is equals to 7. Number 1, we have b subtract ac. So this, in evaluating this particular expression, we need to substitute the terms that we have, or the pronumerals that we have in this particular expression, that is a, b, and c. And we have been given the values of b, a, and c. The value of b is -3, so we substitute b with -3, subtract the product of ac, and our a is 4, our c is 7, so that will be 4 multiplied by 7. When you get, so this will give us -3, subtract 4 multiplied by 7, we get 28. And therefore, minus 3 subtract negative minus 28, you'll get negative 31. Part B, 1 over C multiplied by the difference of A and B. In this particular case, again, we make the substitution. Where there is C, we put 7. So we shall have 1 over 7 multiplied by the difference of A and B. Our A is 4 and our B is minus 3. Therefore, we subtract negative 3. In our order of operations, we said we begin by working out what you have in the brackets. And therefore, this is going to give us 1 over 7 multiplied by minus, and a minus will give us a positive. Therefore, this will be 4 plus 3, which is 7. And finally, when you multiply that, 7 and 7 will cancel out, leaving us 1 times 1, which is simply 1. We want to look at another part of algebraic expression, and that is simplification. Simplification of algebraic expressions. So usually when you have, let's say, 2 added to 2 added to 2 added to 2 added to 2, this means we are adding 2 how many times? 1, 2, 3, 4, 5. And you can simplify this by taking the number of multiplication, which is 5, you multiply by 2. So you'll be able to say that in this particular case, you have simplified from all this to that particular singular solution. Similarly, if we add y added to y, added to y, added to y, added to y, that means we are adding y 5 times, and therefore we can simply take 5 times y, which will give us 5y. Example, simplify the following: a 3 multiplied by 2b. In this particular example, we are having the number 3 being multiplied with another term, which is a number and a pronumeral, 2b. So in this particular case, what you do, you multiply the numbers first. And in this particular case, we shall have 3 multiplied by 2, which will give us 6. When multiplied to b, it will give us a total of 6b. Another example, negative 2a multiplied by 3ab. Again, because this is multiplication, we can be able to multiply the numbers first, that is negative 2 and 3. Then we multiply the pronumerals together, and in that particular case, we shall minus 2 multiplied by 3 will give us minus 6. Then when you multiply the pronumerals, a and ab, a and a multiplied to a will be a total of a squared. Then multiplied by b will give us b. Therefore, the result for that is minus 6a squared b. Number C, 6ab divided by 18b. In this particular case or example, you begin by checking what you have on the numbers. Is it possible for us to divide them? Like in our case, we can be able to divide 18 by 6. And when you divide 18 by 6, you will get 3. So in that case, we shall have 6ab all over 18b. 6 will go there once, 6 will go into 18 3 times. And because we have a b in the numerator and a b in the denominator, they are also going to cancel out. This will leave us with a on the numerator, and on the denominator we shall have 3 multiplied by 1, which is 3. So a all over 3 will be the result. D, 12 a squared b plus 3 ab. Now, we discover that in this particular expression, the pronumerals here or in the first term are a squared b, and the pronumerals in the other expression is a b. Now, in this particular expression, you'll discover that these two pronumerals are not the same. That means that the first term and the second term on the, of the pronumerals are not like terms. They are what we call unlike terms. So since a squared b and ab are unlike terms, we cannot be able to simplify this expression further, and it therefore remains at 12a squared b plus 3ab. That means it has been simplified as much as possible. Now, like terms are pronumerals having or consisting of pronumerals with the same or equal factors. So are pronumerals same factors. So we talk about x squared, another x squared, we can be able to say that x squared and this x squared are pronumerals with the same factors, and therefore x squared and x squared are like terms, and therefore we can be able to operate them by either adding them or subtracting them. So when they contain same factors, we can be able to either add or subtract, and we refer to them as like terms. And like terms are pronumerals containing different factors. For example, if we talk of x squared and x cubed, because this one has been raised to 2 and this one has been raised to 3, we cannot be able to say that the two are the same. We'll say that they are unlike because they consist or they contain different powers, and therefore we can never add them or subtract them. Simplify the following. By collecting the like terms. A, we have 3x plus 4 less 2x. 3x plus 4 less 2x. Now in this particular expression, we are having terms which are like and terms which are unlike. Like in this case, 3x is the same with minus 2x because the pronumerals contained in the first term and in this last term have the same factors or powers, raised to 1, raised to 1. And therefore it is possible for us to either add the first at the last term because they are like. So we are going to have, or when we collect them, we shall have 3x, subtract 2x, then plus 4. 4 is unlike from the others. When you take 3x, subtract 2x, we get 1. Therefore, this one will give us 1x plus 4. This one is simply x plus 4. Part B, we have 3x plus 2y plus 4x plus 7y. Again, if you look at this expression, we have got like terms. The first term, which is 3x, can be matched to 4x because they consist of pronumerals consisting of the same powers. Therefore, you can be able to say that 3x and 4x are like terms. Therefore, we pair them, 3x plus 4x. Then we also have the y's. 2y and 7y are also like terms, and therefore going to have positive 2y, positive 7y. Now 3x, 4x are like, 2y, 7y are like terms. Therefore, when we add these two like terms, 3x plus 4x, you'll get 7x. Added to 2y plus 7y, you get 9y. Now you cannot proceed further because 7x and 9y are not like, or they are unlike terms, because x and y are not the same. C, 8 square of b, subtract 9 ab, subtract ab squared plus 3bm. Now if you look at this, we are also having pairs of like terms. Like this 8a square of b is like to this, because the pronumerals here are ab squared, the pronumerals there are ab squared, therefore we can be able to pair them up. So we shall have 8ab squared, subtract ab squared as one term or when collected. Then ab, or negative 9ab and 3ba. Now it is important for us to note that ab can be written or is the same as ba, and therefore this one can also be written as ab, and if this is ab, then it's going to be in like terms with negative 9ab. So we shall have minus 9ab plus 3ba, which is the same as ab. So these ones are not there. So when you subtract 1ab from 8ab squared, when you subtract 1ab squared from 8ab squared, you get 7ab squared. Subtract. When you take 9 minus 9ab, you add 3ab, you'll get minus 6ab, and therefore this particular expression can be simplified into a two-term expression, 7ab squared subtract 6ab. Now you cannot simplify further than there. Simplify the following. By collecting terms. We have 12 m squared n squared, subtract 2 mn squared, subtract 4 m squared n squared, plus mn squared. Again, if you look at this particular expression, we have two pairs of like terms. Like if you consider these pronumerals m squared, n squared, they are equivalent to that, and therefore 12m squared n squared are like terms with 4m squared n squared. Therefore, we can pair them up. We'll have 12m squared n squared, subtract 4m squared n squared. Then these other two, we have mn squared, mn squared. They also form another pair of like terms. So we shall have 2mn squared plus mn squared. When you get the difference of 12mn squared and 4m squared n squared, you'll get 12 minus 4 is 8 m squared n squared. When you take minus 2 mn squared plus 1 mn squared, because the coefficient of this is 1, so minus 2 plus 1 is minus 1 mn squared. So this will give us 8 m squared n squared, subtract mn squared. The example: a farmer has X pigs and Y chicken. The question is, write an expression for the total number of heads. How many heads does a pig has? 1. How many heads does a chicken has? 1. Therefore, if you have X pigs, the number of heads that will be in that particular farm, or for the number of pigs, will be X multiplied by 1 head each, added to the number of heads of the total number of chicken. So we have Y chicken, and each chicken has got 1 head. Therefore, we shall have Y multiplied by 1. This will give us X multiplied by 1 is X, Y multiplied by 1 is Y. Therefore, this will be the total number of heads in that particular farm. Part B of the question, write an expression for the total number of legs. It is important for us to understand the structure of pigs and chicken. A pig has got 4 legs, that is the 2 front legs and the 2 hind legs, a total of 4 legs per pig. Then a chicken has got only 2 legs, and if you want to get the total number of legs in that particular farm, we'll take the number of legs for pigs, which is 4 multiplied by the number of pigs, which is X. We add to the total number of legs of the chicken, and we are saying that each chicken has got 2 legs. So when we have Y chicken, we shall multiply that by Y. When you simplify this, 4 times X, you get 4X. 2 multiplied by Y, you get 2Y. Final example, a rectangle a rectangle's length is 3 times its breadth, which is X, meters. Write an expression for perimeter of the rectangle Now, given that this is our rectangle, we have been told that the length is 3 times the breadth, and the breadth we have been told is x meters. That means that our length is going to be 3 times that breadth, and therefore the length will be 3x meters. That is 3 times the breadth. And for us to be able to get the perimeter of a rectangle, it's normally given by 2 into the sum of the length and breadth. So in this case, we shall have 2 into, our length is 3x meters and our breadth is x meters. So this will give us 2 into 3x plus x. When you can leave the answer there, or you can expand that. If you expand this, you'll get 2 multiplied by 3x, which will give us 6x plus 2x. Finally, B, area of the rectangle. Now, area is normally given by the length multiplied by the breadth. And in this case, our length is 3x meters and our breadth is x meters. So when you multiply 3x and x, you'll get 3x squared, and because it is area, that was meters. Because it is area, the units will be square meters. So the expression for this rectangular area will be this 3x squared. Now this brings us to the end of the first lesson on algebraic expressions. When we meet next, we shall look at how we can be able to expand algebraic expressions. Thank you.